The first thing that we need to do is capture a screenshot of the reference so that we can get the silhouette. So I'll go ahead and get to our first frame right here. Let's go to our snip and sketch with Windows, say new, and click this to get the whole window, grab that, and save it to reference. Here in Affinity Photo, I have both references loaded up, so we have that and this. We could do a third screenshot, but I've found that sometimes having two shapes works better than three. In this case, we only need two. So I'll press C for crop. We have a 1:1 ratio up here so that it's perfectly square. The Trace Sop likes perfectly square textures, so we'll keep that true. And then all we do is draw out a silhouette of each one of these guys. Also, I'm going to get rid of this little thing over here, that little leg, just because that's more from debris rather than the plume itself. So if we go like that and we just kind of patch it up like so, we should end up with something right about there. And this again represents the silhouette of the plume, not the debris. So that means we are going from this to this. Save the two images out and we'll bring that into Houdini. Now once we're inside of Houdini, let's go ahead and make the Trace Sop. And we're going to go ahead and load that in. So hip, ref, silhouettes, and we have this guy right here. Let's also throw down a transform node, and we can bring this right on up to our point. So turn on point snapping, and there we go. We have that right about here. It's going to be very, very tiny though. So obviously we need to turn this up here in scale. So we'll go up, again, bring this up a tad bit. And looking from the camera, how big do we want this to be? Well, a bit bigger than that. So let's go ahead and bring this up even more. Let's say right about here to start. Maybe a tad bit lower than that, maybe a scale of 5. Same deal, but now this time for the second image. So bring in the second, and now we have this. So let's actually bring both of these guys down so that it's resting right about there. Looking through the render cam, that's how big the explosion is going to be. If we, again, look at our reference, this is taking up a bit more of the frame. It could be closer to the source, but we're just going to bring us up a tad bit more right about there just to be on the safe side. And now we have everything to begin building out this mesh. Let me tell you how this is going to work. So we have points scattered on here. We need to get these points somehow going this way and that way because we don't want just a 2D plane for a source. So we can use the mountain sop to deform them along the normal. This polygon has a normal, so hence the scattered points will have a normal. That'll give us the ability to take them out this way and the other way. However, how are we going to control the distance for these various points? Because we want the guys at the bottom to go further out than the points at the top. We don't want the points up here going all the way out here because then it just turns into a giant blob. So what we can do for that is we can use a volume based on the bounds of that object. So imagine that we have a sphere. It's a beautiful sphere. It looks just like that. And we turn that into a volume where the center is equal to 1, and as it goes out, this equals 0. We can use that data to influence the height parameter of the mountain sop, which again dictates how far away the points go. So as long as something is near the center of the sphere, it's going to be pulled outwards away from the normal. That way, points out here at the edges won't get pulled along as far as the points towards the center as well. And basically, that's going to control how this all happens. From there, we copy over spheres to these points. We take those spheres, apply noise to them, turn them into clouds, use some of the cloud tools to add additional noise, and that will become our source. That's the overall idea anyways. So starting with this guy right here, let's go ahead and scatter some points, turn off the relaxed iterations, and I'm not going to use a mountain sop for this initial trace because that kind of makes the normals all weird and messed up. So if we set a normal before that scatter and I use a mountain, again, this will show you where I'm going. So that now allows us to get away from the 2D plane. And if we turn down the element size, eventually we can turn this into kind of a blobby shape like so. Scatter some spheres on there and you won't be able to tell that it's all spiky like that. And a fun way to break up these spikes is also to use a point velocity. So this guy can take its information originally from the normal. So you say from attributes, that sets velocity equal to normal at first. And then below this, let's make a point wrangle. Again, we have velocity now equal to normal. All we need to do is now make normal equal to velocity. So when we go to add this curl noise, check it out. We can actually change up the direction of these spikes slightly. So that'll add a bit of interesting shapes. And the nice thing about this is that you can say exactly how much of this you want. Or if you want some conical noise, you can do that as well. I would generally recommend going ahead and just sticking with, for the most part, a tad bit of conical noise and a tad bit of curl noise. You don't want to go too crazy with this, but just adding a couple layers of that will make it look less spiky in CG. Take the swirl size down to 25, or to 0.25 that is. And now again, we need to figure out how to taper this from the bottom to the top. Right now, if we create a bound, the issue is that it's going to go underneath the terrain like this. And so that's not quite ideal. We want to, first of all, cut this shape to the terrain. So using an object merge, let's go ahead and find that original geometry. Towards the top, combine geo islands, colliz polys out. Let's give ourselves some room over here as well. With that, we can do a Boolean. We'll go with the original terrain, and we'll go with this guy. We'll say that A is going to be a surface, or actually a solid right there, and B is going to be a surface. If we then subtract them, and I believe it's B minus A, that will give us no polygons underneath here anymore. It'll cut that off. So that's good. From here, we can then create a bound SOP, and we're going to set this as an oriented bounding box, like so. Now, the oriented bounding box isn't going to be perfect because this is totally flat right now, and we need a volume to work with. So let's also utilize the thicken SOP right here, which is part of the Side Effects Labs toolkit. If we do both directions, we can bring out some depth like so, and now our bounding box looks like this. Okay, with that, we can then turn this into a VDB. So VDB from polygons, and we're going to turn that into a fog, fill interior. With the volume slice, we can see that the weight is highest right now in the center, and it goes outwards towards 0. Let's give ourselves some padding though. It's always good to have a little bit of that. So perhaps 1 going right there, and 1 in the lower padding as well. So with a bit of padding, we now need to take the center of this bounding box to the bottom. And we can do that using a transform. So if we create a transform, let's go ahead and right-click the translate, say reference scene data. We'll go up here to our thicken before the bounding happens. And with the thicken, where is it? we can go to our bounding box size and y. That'll bring this up at first. But if we take that expression, we go the opposite direction, and then we only take half of that. So we can just take this whole thing times 0.5. Now, the weight of 1 is going to be at the very bottom of that bounding box, and that's exactly what we want. Now, do be careful though, because we don't have anything affecting the edges along here. So because we moved the bounding box by half of the size in y, we can add the same amount of padding as well. Take this whole thing, and let's go to our bounding, and just simply paste that in, and don't do that negatively. So we do that for all the fields here. Okay, and after pasting that in, we're now good. We have enough room to really account for everything. So if we go to the very, very top, we see that that's now where 0 hits, and that's exactly what we want. 1 is down here, we go up to 0. So everything is working great. The last thing we need to do now is take that information from the volume and apply that to the height attribute. So point wrangle, we'll plug that into the mainstream before the mountain 2. First of all, we need to sample these volume values. So let's create a float, call this sample vol. It's equal to the volume sample function right here. That's going to go through index number 1. That's the second input. We're looking for a field called density to get our values, and let's take our current position right there. That is going to be equal to height, just for the time being. As soon as we do that, we go to our mountain, and we can see that this is already working. Towards the top, we have nothing. Towards the bottom, we have a value of 1. So that's great. But we want more control than that. So let's use a channel ramp. And we'll call that channel ramp our height control. And with that ramp, we can determine the fall off however we want. So click on that guy. And now I can really dial in exactly how I want this to go down. So let's say we do something maybe like around here, and then, add a bit of variation in here. It's sometimes good to do that. And I think that will do just fine. Now, if we want to take this up in general, we can multiply that value times a float, and we can call this our height underscore mults. Now, we have a way to just bring everything up like that. And we've successfully tapered all of this like so. One last thing to do. If we have these points underneath the terrain right here, we want to bring them above the terrain. And we can do that using the ray SOP. So let's take a copy of our geometry. We'll say ray. That's going to be our collision primitives. This whole collision mesh right here. So that guy is going to be the collision mesh, and we want to send some rays. But we only want to do that for the points that are underneath the ground. So if I take a group SOP and I set that up to our terrain, we can then go to keep in bounding regions, bounding objects, set this to our ray points as a point group, and then only those points will search for the areas along the terrain. So now we can go to our group in the ray SOP, say ray points, set the entity to the points, and look for the minimum distance. That will bring all of these points up to the surface. Also, if we then bring a little bit of lift, that could add even just a bit of extra detail. Don't go too far on that lift, but just a tad bit would be sort of nice. So, there we go. Now we have this, and to see what it looks like, copy the points. There's our points. Bring in a sphere, and voila. We now have this sort of thing going on. All right, great. In the next video, let's continue on by adding more detail to this source.